Hey folks, Sega Sonic fan here with another not so great video quality video, but I wanted to show off some reverse engineering here. I guess it's a reverse engineering, whatever day it is. So you can get these cool little um, portable power banks that you put your own battery into, just the motherboard like so, and then you put in your own 18650 battery cell. This is from an e-bike battery that is no longer with us because the motherboard died and it's got a custom flashed EEPROM, and screw that, took the batteries out. So yeah, this board is like, it's like $150 for the board and the case, which is insanely cheap. Um, Actually too cheap in my opinion. There's probably some sweatshop labor going on there. And also, because it's so cheap, there's really a lot of missing components on this board that should be populated, but aren't, because they're kind of like, whatever works, works. So I don't want to destroy a $100 phone because this is, 50 cents instead of $1.50, or actually probably much less to manufacture. So I'm doing a little bit of research on the chip here. It's labeled MP3402B, and I couldn't find anything on the B variant, but the letter at the end. But I did find this website, which is a Chinese website, and has the demo board for sale. And this is really useful because it has a schematic here. And this schematic is going to show us what parts are not being populated, and from that we can deduce what they do and why they're not being populated. Um, and so if we look closely here, unfortunately my camera is not great at close-up stuff, but there's a capacitor missing here. It's a capacitor and a resistor missing there that there's no footprint for. And then there's two missing footprints over here. Quick overview, this is just a simple lithium-ion charger. However, it's got a couple other interesting components to it. It's a step-up converter as well. It steps up the lithium-ion cell to a steady 5 volts. And I'm not sure what the power capabilities are. I guess this is claiming 0.7 amps. It's probably 0.7 amps output, 1 amp input. I'd have to translate that. But my guess is it's going to be quite a bit lower, to be honest. Since this is, just total jankiness here. But one of the capacitors it's missing, which actually is not missing, but just populated incorrectly, or placed incorrectly. So you go through this inductor here from the positive rail, and then there's a decoupling capacitor. Now, I'd bet money that that is not the proper way to set that up, and that in fact the decoupling capacitor is supposed to go closer to the input, because that's what it's for. It's a decoupling capacitor, and not close to the chip. Though I could be wrong about that. There is a decoupling capacitor here as well that is missing. Oops. At the 5 volt output. I'm sorry, this is the charging input. So both here and here are missing decoupling capacitors. In fact, actually, I take that back. This one is present for the 5 volt output. It's right there. So it's just the 5 volt input, the charging input, that's missing a decoupling capacitor. And so I'm going to go ahead and populate that. It's a 1 microfarad capacitor. And then we have this this stage here, which is an RC network on the inductor input. I don't know what that's for. Oh, geez. Come on, stupid phone. But it's, I'm going to go ahead and populate it anyway. Because it can't be bad. It's on the demo board. It could be for smoother, I don't know. A lot of times, extra components like that will be for a better efficiency or something like that. Less noise, who knows. Can't be bad, so I'm going to go ahead and populate it. And then we have our two LED outputs here, which are actually tied directly to the chip and don't even need resistors, which is interesting. They are bright as hell, and I'm really unhappy that the red one, I used to have an older model one of these, but the red one, it now blinks when it's charging, and I cannot stand products that have blinking LEDs with charging. It's really annoying. Either have it do the fade thing that MacBooks do, or have it just be a solid red. The blinking just lights up your whole room in a really annoying way, on and off. But yeah, I don't know if I'm going to do anything about that right now. Just trying to get this a little bit safer. Last but certainly not least, there is absolutely no fuse on this thing. Your power input comes in right here, your negative minus and plus are right there. And the plus goes straight to the inductor and straight to the chip. There's literally nothing there. So my first battery on one of these, I had two of these, and I put the battery in. One of the tabs wasn't ripped off completely from the battery pack I'd pulled it from, and it shorted, and it instantly blew out this chip. And that's also just kind of dangerous. You really need to have a protection fuse. So there's no overcurrent or undercurrent or overvoltage or undervoltage protection circuit in here either, which also makes this dangerous. If you have a nice phone and you're smart and you have money, don't buy this. Just don't even do it. Get yourself one that has proper protection circuitry and be smart. If you don't have a lot of money and you're dumb like me, you can hack this like I'm going to do. But it's still pretty dumb, to be honest, and I could break something eventually because this is just total crap. And what do you expect? It's like $1.50. So yeah, for those that don't know, most lithium ion, all proper lithium ion, lithium polymer have a protection circuit, which is meant to monitor the battery cell and make sure it doesn't crap out. And this doesn't have that. So there you have it. There's your DIY deal. I'm going to put a capacitor here. I'm going to put the RC network over there, and I might cut the trace and install a 0603 fuse over there. Have fun hacking and be smart. I take no responsibility for if you blow yourself up or catch on fire by doing something dumb. This is no protection circuitry. Be smart. This is Sega Sonic Fan, signing out.